This video is about a review for the final exam. Let's start the first question. Question number 1 is about the population growth. If you read the question carefully, and let's see what is given here. You see 4% base rate is given. It tells you the growth follow logistic model, and the carrying capacity is 60 million, and the actual growth rate, you got to find that when the population is 10 million. So you have three numbers here: base rate 4%, carrying capacity 60 million, and you got to find the actual growth rate when the population is 10 million. And there is a formula for that, and I'm going to write the formula. You'll find the formula from the list. Here's the formula. Logistic growth rate, which is same as actual growth rate. Okay, that's I'm looking for, actual growth rate. Okay, that's the formula here. I'm going to write the formula. Equals to base rate times 1 minus population divided by carrying capacity. I can write carrying capacity as a CC. Okay, so that's the formula. So base rate here is 4%. We change 4% to decimal, 0.004 times 1 minus population here is 10 million divided by carrying capacity is 60 million, and this million cancel. You obviously see that. So you multiply 0.04 times 1 minus 10 over 60. So if you use the calculator to simplify this expression, you get the growth rate, which is going to be, if you do the calculator, it's going to be 0.03333, which is similar to 3.33%. That's the actual growth rate, which is also called logistic growth rate. All right, question number 2, which is second question. The consumer price index is increasing at the rate of 1.1% per year. Okay, that's the rate, 1.1% per year. What is the doubling time? You're looking for doubling time, and you have to use the approximate doubling time formula. It's called rule of 70 to find the doubling time. So here's the formula: doubling time by rule of 70, T double equals to 70 divided by P. Note that we use this symbols here. This is called approximately, not like pretty much equal here, where P is called percent. P is called percent per time. So that P we're going to use here. Don't change the decimal, because that's what we're using here, 1.1 as a percent per year, per time. Here time is year. Okay, so we're looking for doubling time if consumer price index is increasing 1.1% per year. So we use P as 1.1, 70 divided by 1.1 per year. So if you do the division, 70 divided by 1.1, and you round your answer to the nearest year, which is going to be 64 year. So if consumer price index increases in that rate per year, the doubling time going to be 64 year. Okay, next question. Isabella is a head of household on wages of 88,750. That's her income. That's the income, and received $4,900 as in interest from the saving account. So that's also income. So there is two income here, 88,750, that much, plus her interest from saving account is 4,900. That's the income. So that's her income. That's called gross income, because that's all she has. Total income is gross income. So how much total gross income? That's I'm looking for. Is if you add them, it's going to be 93,650. That's the gross income. Now, next question is looking for. Oh, it doesn't tell you, but again, in this question, I'm looking for three things. I suppose I mentioned here, I forget it. You're looking for gross income, and you're looking for adjusted gross income, and looking for taxable income. That's three things here. Not bad, but I'm going to add it later. Okay, so you have a gross income, you got to find that. You have to find adjusted gross income, and you got to find the taxable income for Isabella. So we found the gross income. That's our total income. So to find the adjusted gross income, you subtract adjustment here. The adjustment is tax deferred amount. Here she contributed 6,200 to tax deferred retirement plan. So this is not taxable. So you subtract that from the gross income to find adjusted gross income. So to find the adjusted gross income, you always subtract tax deferred amount here. So to find the adjusted gross income, you subtract 6,200 from 93,650 minus 6,200. So whatever you get, this is going to be 87,450. That is adjusted gross income. Okay, we found the adjusted gross income. So now what's the taxable income? So here's a formula for taxable income. Taxable income equal adjusted gross income minus deduction. That's the formula. So here there's two deductions here. There's itemized deduction, which is given here, $90,050 itemized, $90,050. But the other deduction is standard. But the standard deduction is given in the table. In the question, there should be table. Table looks like this. So if you look at this table, this is called tax bracket, and you're looking for filing status here: single, married, filing jointly, married, filing separately, and head of household. Since Isabella is head of household, her standard deduction is 18,800. Okay, you got to look at this standard deduction. There's two deductions here. So Isabella standard deduction is 18,800, but her itemized deduction is 19,050. So she has bigger itemized deduction, so she wanna deduct this number itemized deduction, which is 19,050, not the standard. So do not use standard because itemized is higher. So you subtract itemized deduction from the adjusted gross income. That means 87,450 minus $19,050. Again, you have to look for which one is higher. Then you subtract the higher deduction. Okay, but in this case, itemized deduction is higher, and we're subtracting this. When you subtract it, you get 68,400. That's her taxable income. So it's a taxable income. Okay, I know that right here. Taxable income. The next question. The pH of the solution increased by 5. Notice that pH is increased by 5. That's the given tells you if. How much the hydrogen ion concentration changes. So here, if you increase the pH by 5, how much hydrogen ion concentration changes? And next part of the question is, does this change make the solution more acidic or more basic? That's the question. So if you increase the pH, hydrogen ion decreases. So here's the thing. For each unit increase in pH, hydrogen ion, we call H plus as a hydrogen ion, okay? It's called hydrogen ion. Hydrogen ion. H-Y-D-R-O-G, and hydrogen ion decreases by a factor of 10. So if we increase the hydrogen ion by 5 units, increase by 5 units, each unit is 1 unit, okay? If you increase by 5 units, 5 increase in pH, the hydrogen ion decreases by 10 times, 10 times, 10 times, 10 times, 10, which is going to be 100,000. Or it's called 10 to the power 5. So if you increase pH by 5 units, the hydrogen ion decreases, notice that, decreases by 10 to the power 5 times. That means the solution becomes more basic. So hydrogen ion tells you, is that acidic or basic? More hydrogen ion, acidic. Less hydrogen ion, basic. So more hydrogen ion, acidic. It's like a chemistry problem, okay? If you are chemistry students, you might know that. More hydrogen ion, acidic. Less hydrogen ion, basic. So in this case, the hydrogen ion decreases by 100,000 times. So the solution becomes more basic because we have a less hydrogen ion. Okay. Question number 5. Compare the energy of the magnitude of 6 earthquake to that released by a 1 megaton of nuclear bomb. It tells you how much energy is released by 1 megaton of nuclear bomb. That 5 times 10 to the power 15. This is, notice that I read slightly different way. This is going to be 5 times 10 to the power 15 joules, okay? Joules. So this is the energy released by 1 megaton nuclear bomb. But the question is, how do you compare this energy by 6 magnitude earthquake? So 6 magnitude earthquake has m equals to 6. In the formula, 6 represent m. And what's the formula? Here is the formula. Energy released by earthquake E equals 2.5 times 10 to the power 4 times 10 to the power 1.5 m. That's the formula. Again, if you remember that when you did this before, you use this formula to find the energy released by earthquake. So here m is the magnitude, and you substitute the m value here, 2.5 times 10 to the power 4 times 10 to the power 1.5 times 6, and you multiply 1.5 and 6, you get, let's do the math here, 2.5 times 10 to the power 4 times 10 to the power 9, because 1.5 times 6 is 9, and you use the exponential rules. You add this exponent because the same base 10 10, you guys get 13. So this much joule. So the energy released by 6 magnitude earthquake is 2.5 times 10 to the power 13 joules, and energy released by nuclear bomb is 5 times 10 to the power 15 joules. So you divide 5 times 10 to the power 15 joules by 2.5 times 10 to the power 13 joules, and you can see how many times bigger the energy you get from nuclear bomb as compared to the 6 magnitude earthquake. So if you do math here, the joule divide, and again this is the exponent rules. If you remember that x to the power a over x to the power b equals x to the power a minus b, and I'm going to use that rule here. 10 to the power 15 time divided by 10 to the power 13 is going to be 10 to the power 15 minus 13, and then 5 divided by 2.5 is going to 2. So you get 2 times 10 to the power 2 is going to be 200 times. So if you compare, you can say that energy released by this 1 megaton nuclear bomb is 200 times bigger than energy released by 6 magnitude earthquake. Okay, next question, conversion of the unit. A, convert 420 miles per hour to miles per minute. Notice that you are given a conversion table and you use that table to convert, right? So 420 miles per hour, that means 420 miles divided by 1 hour. That's what we call 420 miles per hour. So I want to change to miles per minute. So basically miles is in the top, and the per minutes means minutes has to be in the denominator, but there is an hour. I got to change hour to the minutes. How you do that? 1 hour, you got to use the conversion factor, and you notice that 1 hour equals to 60 minutes. So what happens if you do that? This hour cancel, and you multiply 420 times 1 is 420 miles in the top, divided by 1 times 60 is 60 minutes in the bottom. Notice that bottom is in the per minutes. The per is the division, so you to divide that, you get 7 miles per minutes. That's what we call. All right, for B, 43 ounce to pound. 43 ounce to pound. So 43 ounce, you got to change the pound, and you have to remember that how many ounce equals to how many pound. And again, you are given a table for the conversion. You look at it, the table, and the table says 1 pound equals to 16 ounce. So what I'm going to do here, I put the ounce here and the pound in the top, lb as a pounds. So I should say 16 ounce equals to 1 pound. Okay, so I need to put the ounce in the denominator because I got to cancel this ounce with this ounce, and my answer is going to be the pound that I'm looking for. So basically you can see 43 ounces over 1, just 1. So ounce cancel, and you multiply 43 times 1 is 43 pounds in the bottom. Again, lb in the top, lb as a pound, and 16 times 1 is 16. Remember that this ounce cancel. 43 divided by 16 pound, which is gonna gives you 2.68 0.75 pound. Okay, notice that this is the 16. Okay, it's not like B here, the 16. So again, read the instruction on the questions, how many decimal you rounded, but that's the exact answer. Or say you change 60 fluid ounces to gallon. You are given this table on the test, so this table here, and if you look at this table or this table here that is provided, and you have to look for is there an equation that convert fluid ounces to the gallon directly. No, really, remember that there's no equation that tells you how much fluid ounces equals to how much gallon, right? So what you have to do is you change first fluid ounces to here in ml, okay, right, ml, milliliter, and you got to change that ml to the gallon, because you know 1 liter, that means 1000 milliliter equals to this much gallon. So this equation involve multiple use of multiple conversion factor. So I'm going to use convert this first to the ml, because I have this equation. It tells you how much fluid ounces equals to how much ml. Okay, so 1 fluid ounces equals to 29.574 ml. So I'm going to do that. So I'm going to write fluid ounces here because I want to cancel that. It has to be in the bottom. So 1 fluid ounces equals to how many ml we read before. This is 29.574. So 29.574 ml. So I got to change milliliter to liter. So that's not difficult because 1 liter equals 1000 milliliter. So now if you see that equation here, fluid ounces cancel, milliliter cancel, you get liter. That's the unit that left so far. But I got to change to the gallon here. So to change the gallon, I'm looking for the conversion factor with liter and the gallon, and it is here. Watch, liter and gallon. See, 1 liter equals to 0.2642 gallon, or you can use 1 gallon equals to 3.785 liter. Doesn't matter which you use. If you use this one or this one, this is fine. So I'm going to use this one. That is 1 gallon divided by 3.785 liter. So this liter cancel again, and you see this whole equation. You multiply 60 by 29.745 times 1 in the top. How much you get? Whatever you get in the top, and the bottom you multiply 1000 and 3.785, and you get the answer in the gallon. Okay, so multiplying the numerator, that gives you 1774.44, and multiply denominator gives you 3785, and if you divide, your answer is going to be rounded to, depends on the instruction. I don't have instruction here, but I usually round it to 3 decimal or 4 decimal. Here I do 0.469 gallon. So finally, what you understood here is 60 fluid ounces equals to 0.469 gallon. All right. Next question, we convert barrel to the quart. Okay, for the 400 barrel, BARRELS, the barrels is a volume units. Again, you are changing barrel to quarts. Let's see, we have an equation that convert barrel to quarts. Let's see. Here you go. So there is no directly from barrel to quarts. There is barrel to gallon and gallon to quarts. So you have to use 2 conversion factor. Remember that there is 2 barrel. One is barrel of liquid, other is barrel of petroleum. There is different volume. So since doesn't say petroleum, you usually use barrel of liquid. So 1 barrel of liquid equals to 31 gallon, and 1 gallon equals to 4 quarts. So you have to use these two conversion factor to change barrel to quarts. So I'm going to use 1 barrel of liquid equals to 31 gallon. Then I want to use 1 gallon equals to 4 quarts to change it. So I'm going to go back here. So 1 barrel equals times, and the or EL goes to the bottom, the top goes to the gallon. So, and as you see before, 1 barrel equals to 31 gallons. But again, I got to change eventually the quart. So I got to see how many gallon equals to how many quarts. And this is 4 quarts equals to 1 gallon. I need the gallon in the bottom, quart in the top, because I got to cancel gallon with the gallon. So if I do that, this barrel cancel, gallon cancel, and your unit is going to be in the quarts. That's what I want here. Look at here, quarts. So we multiply 400 by 31 by 44. That's the answer. Remember that denominator is 1, so it doesn't matter. Dividing by 1 is same as the number. So let's multiply, and that gives you 49,600 quarts. So the barrel 400 equals to this much quarts. Okay, part E. You got to change yard to furlongs. 76 yard to furlongs. And again, you go back to the table and see furlongs. What is the furlongs? And do you have an equation that has furlong and the yards? Let's see. Furlong. What is furlong here? This is the length, by the way. 1 furlong equals to 40 rods equals to 1/8 mile. So they gives you furlongs equals to miles as an equation, and I got to change furlongs to yard to furlongs. So you guys see how many yard equals to how many miles. Somewhere here, 1 miles equals to 1760 yards. So I'm going to use two equation. 1 furlongs equals to 1/8 miles, and 1 miles equals to 1760 yards to change that yard to furlongs. So what I'm going to do here is I'm writing 76 yard times, I got to put a yard here in the bottom. I'm going to put miles in the top because I cannot change yard to direct to the furlong. I got to change first to the miles. So 76 yard miles, how many miles? 1 miles equals how many yards? 60 yards. Now notice that this yard cancel, and since I need the answer in the furlong, and I know how many miles equals to how many furlongs, so times, again, if you look at the chart, how many miles equals to how many furlong? See, 1 miles, I should say 1 furlongs equals to 1/8 miles. Okay, so 1/8 miles equals to 1 furlong. Let's write FL furlong. Okay, 1/8 is 0.125 miles equals to 1 furlong. So what I'm going to do here is I'm going to write furlong at the top, which is going to be 1 furlong, and the bottom going to be 0.125 miles. Okay, because 1 furlong equals to 1/8 miles, which is 7.125 miles. Now this miles cancel, and your final answer is going to be furlong, and you simplify. That gives you all together, when you simplify, this gives you 0.345 furlong. Alright, because see, that's the unit that left in the equation, so that's the final answer unit is furlongs and 0.345 furlong. Poaching is causing a population of the elephant decline by 5% per year. Use the approximate half-life formula to determine the fraction that remains 59 years if there are 8,661 elephants today. This is the initial value is this much, and the question tells you how much elephant remain if they are declining 5% per year. So you got to find first when gonna be elephant gonna be half. So first you got to find that t half. In other words, what year they're gonna be approximately half the elephant if they decline 5% per year. Then t half formula equals to 70 divided by p. That's the formula we used that before as well. So 70 divided by p here is percentage, which is 5. This gives you 14 year. So in the 14 years, the elephant is going to be half if they decline in that rate. So we are looking for how much fraction they remain after 59 years. Notice that they becomes half in 14 years, but in 59 years the population declined a lot. So you got to find how much fraction remain. So let's do the formula. The new value equals initial value times 1/2 to the power lowercase t divided by t half. Lowercase t is the time that is I'm looking for what fraction is going to be remain on that year. So this t half is when going to be elephant going to be half. What year elephant going to be half? So that's the t half, and that's the formula. Initial value. I don't want to put right now initial value. I just keep it initial value right now. Initial value, as I know initial value is this much here, but I want to keep for a moment. Initial value is going to be half to the power t is 59 divided by 14. And if you do this in the calculator, again you might have a scientific calculator or graphing calculator to find half to the power 59 divided by 14. If you do that in the calculator, you get this. Let me write down here INITIL initial value, initial value, VALU value, and this gives you 0.053873. I rounded a couple of decimal, so this much fraction, that means this much fraction remain after 59 years. This much fraction remain after 59 years. So if right now the elephants are 8,661, so put 8,661 is the initial value. How much is the elephant going to be? Okay, question number 8. The following tables give the popular and electoral votes for to measure candidates for the various president's election. State who wins the popular vote and who becomes the president. And here are the examples here. So 2016 Donald Trump get 304 electoral votes and 227 Hillary Clinton get an electoral. To win the election, the popular vote doesn't matter. They have to win electoral vote. So 270 or more electoral vote win election for president, right? For PRESIDENT. So in 2016, the question is who won the electoral vote to become a president? Is Donald Trump, 304 votes, so Donald Trump become president. And the popular vote is Hillary Clinton got more, 65,844,969.